Hello everyone, welcome back to the Math Fun Room, your favorite place to hang out. I am Brian Macon. We're going to begin learning about the many applications of trigonometric functions. In particular, in this video, we're going to learn how to solve triangles, which is going to give us a foundation to solve some really awesome and fun applications. So let's get started. In the discussions that follow, a right triangle is always labeled so that side A is opposite angle A, side B is opposite angle B, and side C is the hypotenuse. Note that we use capital letters to represent the measure of an angle and lowercase letters to represent the length of the side of the triangle. To solve a right triangle means to find the lengths of its sides and the measurements of its angles. We express the lengths of the sides rounded to 2 decimal places and angle measures in degrees rounded to 1 decimal place. Make sure that your calculator's in degree mode when you start doing this work. To help with the process of solving right triangles, recall that angles A and B are acute and are complementary. That is, angle A plus angle B equals 90 degrees. Also, we can use the Pythagorean theorem, which says the square of the hypotenuse equals the sum of the squares of the legs. We write this as c squared equals a squared plus b squared. Lastly, we can also utilize the 6 trigonometric functions. For example, we know that the sine of an angle is the ratio of the lengths of the side opposite of the angle to the hypotenuse. Let's now consider an example of solving a right triangle. In this problem, we're given the following right triangle, where side B equals 3 and angle A equals 34 degrees, and are asked to find side A, side C, and angle B. So first, let's find angle B. We know that angle A plus angle B equals 90 degrees. So 34 degrees plus B equals 90 degrees, and therefore B equals 90 degrees minus 34 degrees, which equals 56 degrees. Next, let's use the tangent function to find side A. We know that tangent of 34 degrees will be the ratio of the lengths of the side opposite to the side that is adjacent. So we can write tangent of 34 degrees equals side A divided by 3. Therefore, 3 times tangent of 34 degrees equals A, and A is approximately 2.02. And just a quick note to make sure the calculator's in degree mode, and we would round to 2 decimal places for lengths of sides. Next, we're going to use the cosine function to find side C. We know that cosine of 34 degrees will equal the ratio of the lengths of the sides adjacent to the hypotenuse. So cosine of 34 degrees equals 3 divided by C. Therefore, C times cosine of 34 degrees equals 3. Dividing both sides by cosine of 34 degrees, we have C equals 3 divided by cosine of 34 degrees, which is approximately 3.62. All right, I want to make a quick note here that the reason I chose to use the cosine function to find side C is because it involved the information that was provided in the problem and not any quantity that I had calculated. I personally like to use this approach so that I'm not involving any values that have been rounded to an estimate before I make the calculation and then round a second time. Now let's look at an example where we are given the following right triangle where side B equals 5, side C equals 8, and we're asked to find side A, and angle B. First, let's use the Pythagorean theorem to find side A. We know that a squared plus b squared equals c squared. So we have a squared plus 5 squared equals 8 squared. Therefore, a squared equals 64 minus 25, and a equals the square root of 39. Rounding to 2 decimal places, we get that a is approximately 6.24. Now let's find the measure of angle A using the cosine function. Again, I'm going to use the cosine function in this case because it involves the information that was provided in the problem and not any quantity I calculated. And we know that cosine of angle A will equal side B divided by side C. So cosine of A equals 5 over 8. To find angle A, we're going to use the inverse cosine function and say that A equals inverse cosine of 5/8. Making sure again we're in degree mode in our calculator and rounding to one decimal place, angle A is approximately 51.3 degrees. Now let's find angle B using the sine function. We know that sine of angle B will equal the ratio of side B to side C. So sine of B equals 5 divided by 8. Now we're going to use the inverse sine function, and we have angle B equals inverse sine of 5/8. Angle B is approximately 38.7 degrees. Notice that we could have found angle B using the fact that angle A and angle B are complementary. So angle A plus angle B equals 90 degrees, which means that B equals 90 degrees minus A, which is 90 degrees minus 51.3 degrees, and that is 38.7 degrees.